So, welcome to our last session for this year's conference, digital one. We have a wonderful topic to wrap it up. I would like to introduce you in this last session to Mr. Jonathan Lundin, who brings 25 years of experience in the technical communication industry with him, and currently works as an information architect at Exosoft. Besides that, he researches at Mälardalen University in Sweden on user seeking and reading behaviors. And based on that, his topic today deals with the importance of including conceptual information in your manuals and as well as their purpose. If you have any questions, please feel free to write it in the window, in the question window on your panel, and we will answer them then at the end of the presentation. So, Mr. Lundin, the stage is yours. I hope you enjoyed this last session.
Yes, thank you very much. I hope you can see my screen. So I'm presenting.
Yes, we do.
Perfect. So I will turn off the camera shortly so we can focus on the slides. So we'll actually do it now. So, welcome to this last session of TC World. So my name is Jonathan Lundin, and the title of my talk is, Do we need to write conceptual information in manuals? Before we start, I would just like to introduce myself and give you a little bit of a short background to why I'm giving this talk. So I am a technical communicator, which I guess most of you are. And my experience is working with XML-based content management for manufacturing companies. And I work as an information architect. I have a background in the development of the data standard. So I was in Oasis back in the days, participating in the machine industry subcommittee, which was a lot of fun. But I'm really interested in user behavior and how users search and read and what impact that might have on the design of technical communication. So in my PhD, I studied these behaviors and I proposed a design for technical communication. So some of the insights that I've gained throughout my research, I will share with you today. So I work for Exosoft, and Exosoft is a vendor of the Scribenta component content management system. And here are some of the companies that are using Scribenta to manage, publish, translate, and version handle their technical documentation. So me and my colleagues, we focus on helping, of course, these companies to optimize their processes. But the thing is, I'm a technical communicator by heart. And as technical communicators, we think about the end users, the target audience. And we try to figure out their information needs and what to write, what information types, and how to organize and structure that content. So two main information types is, of course, task-oriented information, step-by-step procedures, but also conceptual information. And conceptual information to me is information that describes the hardware or software. And conceptual information can be structural, meaning that it describes the parts a product consists of and how these parts relate and their name. It can also be functional, meaning that it describes how the hardware or the software works. So there's a time perspective, there's a signal flowing through various filters, for example. In the research literature, conceptual information is referred to as declarative system, expository information, or descriptive information, or sometimes as principles. And this conceptual information, at times we embed it between action steps in the step-by-step procedure. But most commonly is that we create, for instance, concept topics that would make up a separate chapter in the manual. And conceptual information can be distributed by traditional PDFs or micro content or chatbots. So it's still a relevant information type. Now, I have an experience of when I started as a technical communicator back in the days. And I asked the R&D product manager about input, and I received the product specification. I read it and I said, okay, here's a lot of conceptual information. So should I include all this conceptual information in the manual? Well, I was trying to figure out who's going to read this to do what then. So I came up asking the product manager, but then they said, yeah, we need to include it. We need to include all these descriptions and how the software and hardware works. But I say, why? Why should we do it? Who's going to read this? They said, but isn't it obvious? We need to tell the user what we have designed. We have spent billions of years of designing this product. So we need to tell the user. I don't remember how the argue went. It was a long time ago, but anyhow, I think there still is an uncertainty when I talk to my fellow technical communicators on if we should include it and what purpose it has. And we spend a lot of time on writing and translating it. So yeah, the question is really, do we need to write it? Well, this talk, I'm going to divide it into 3 parts. So first, I will position conceptual information within the user's learning path. So there's a learning process that happens. After all, technical communication to me is, the purpose is to support the end user to learn, meaning to go from a situation where they cannot independently do a work task to a situation where they can. That's a process of learning. So I will position conceptual information within this learning process, and then dig into a number of challenges that happens when the learner is trying to search and read conceptual information. And then end with a conclusion, so make a recommendation for you based on today's talk. Okay, so let's start with the learning process and look into the end users. So here we have Eric and Anna, 2 users, and Eric to the left, he is a new employee in this workshop, and Anna is the senior expert who is supporting Eric to learn, and Eric is responsible for a number of work tasks that he's supposed to do. So let's look into Eric's learning path the first weeks in this workshop. So let's put him in the background, and then this timeline here depicts Eric's first weeks. So the first week in the workshop, there is a task that he can do by himself. He can disassemble the air filter. So he has, from school, he has learned, so he doesn't need support from Anna or looking into manual. At the same time, there are other tasks like assemble the carburetor, which he cannot do by himself independently, but he can learn if he is supported by Anna. And at the same time, there are other types of tasks which he cannot learn even if Anna will support him, since they are too complex, like assemble the gearbox or configure the electronics. Now, let's say that Eric collaborates with Anna to learn how to assemble the carburetor. So the second week, Eric can still disassemble the air filter, but he has then learned how to assemble the carburetor. So there's a process of learning and development happening here. And once he has learned how to assemble the carburetor, he is in a position to learn how to assemble the gearbox. And so it goes. The configure electronics is still too complicated the second week. The third week, he has actually learned how to assemble the gearbox. So again, he has collaborated with Anna and learned how to do it. And now he's in a position where he can start to learn how to configure the electronics. This view of the learning process, I'm using a theory called the social culture theory, which was coined back in some 100 years ago by a guy called Leo Vygotsky. And his theory deals with how learning and development unfolds in a social cultural context, meaning learning and development of cognitive abilities or knowledge. And this theory tells us that learning happens when a more knowledgeable other, like Anna, supports or acts as a scaffold for the one who is supposed to learn. And this theory is very relevant, I think, for technical communication, because we are the more knowledgeable other. We are Anna, who supports the user. So the text, the images, and the videos that comes through in the PDFs or the chatbots or the micro content, is the voice of the more knowledgeable other. And this is interesting, this theory, I think, because if you look at minimalism, and those for you who are into minimalism, you know that minimalism largely is built upon the knowledge theory from Piaget. Piaget tells us that we learn by our own discovery and our own exploration. And Vygotsky's theory is in many respects portrayed as being very diametral different to Piaget's theory. So I think the field can learn a lot from using Vygotsky. We can vitalize the field. But what does it really mean to learn? If we look at the arrow here, pointing upwards, when Eric is learning to assemble the carburetor. Well, I think it has to do with mental models. Now, let's look here at the person who's trying to learn. In this case, it could be Anna, actually. She also needs to learn certain tasks. So she navigates to a technical documentation knowledge base about air filters and tries to read conceptual information. So what happens when she looks at the interface and tries to read the icons and symbols? What happens? She has knowledge in her long-term memory, which she has developed over the years. So if she can identify the words, the things, symbols, and icons that she's seeing, so there's an identification phase, air, machine, filter works. And if she has knowledge about these things in a long-term memory, she's able to shape a mental model, which lives in the working memory. So this is a mental representation, which is dynamic and changes as she's seeing and interacting with things. In this case, this mental model reveals how the air filter works, which she's reading about, and also how it is used. So the mental model is both procedural and system-oriented. Now, having learned means that we are able to shape a mental model, that we have developed knowledge. And based on this mental model, the user, and in this case, can further shape goals. What goals are appropriate to have once I know about this product? And I can also plan how to reach these goals. So to learn, to me, means to actually be able to shape a mental model that is correct in respect to how the device, the hardware or software works. So let's look at an example of. So I would actually now ask you to read a text and try to read it and see if you can figure out what this is all about. Okay, so I will stop you there. So the thing is, could you make any sense out of reading this? What was this text all about? And if possible, you can write, I think, in the chat if you have any ideas. Maybe if Alexandra, if she could pick some samples and tell us if there are any suggestions what this text was all about.
I'm sorry, I was muted. So there are answers. Is that cleaning up in the workshop? No clue. Perfect nonsensical text. Tidy up at a workshop.
Yeah.
Washing
Okay.
the dishes.
Yeah.
No
yeah,
to general, no precise terms.
Exactly. Yeah, really good comments. So of course, this text comes from a handbook of reading research. So it's deliberately designed to be difficult to understand. But what happens if we put this is the exact same text, we add a title and a photo? And most readers will now say, ah, okay, now I get it. So what happened here? The first time you read a text without the title and the image, you couldn't connect to your knowledge because the terms was very vague and very generic, the procedure, items, groups, facilities, etc. But now when we added the title and the image, those act as instructions to tell you which knowledge to activate to be able to shape a mental model. So once the title and the photo is added, you can shape a mental model, because I assume that all of you have experiences of washing clothes. I hope so, at least. So this means that now you can put it into life. So you know what procedure means, facilities perhaps, machine, etc. So this example simplifies, like Eric, in the beginning of learning, if you lack domain knowledge, or if you cannot connect to your knowledge, then you cannot shape the mental model and you cannot understand. So let's look into Eric's learning process a little bit more in detail. Given that Eric now tries to start the work task to assemble the carburetor, so he looks at the machine, he tries to identify the parts, and he tries to connect to his knowledge to shape a procedural mental model. Let's say he can do it, and then he starts to act. So he starts to execute the action steps, and he fails. Well, things doesn't go wrong. So he sets out to seek for support. Anna is on vacation, so he has only the manual designed by a technical communicator available. So he searches and reads an instruction and finds it. Now, reading this instruction also means that you shape a mental model from reading, similar to looking at the interface on the product. Now, as he can shape a mental model from the instruction, he can then extend or modify the previous procedure that he shaped before reading. So he says, aha, okay, I need to fasten the ABC also. Okay, I didn't know that. So then he goes back, he tries to continue to perform the work task, and he fails again. So this time he sets out and finds conceptual information. So this seems to be a common behavior. That first we seek instruction, and then if we fail, find conceptual information. Now, the thing with conceptual information then is that by reading it, we can shape a mental model on how the carburetor works and its parts and how they relate, from which the user can infer the actions to do. So by knowing about how the system works and its parts, one can infer, can draw conclusions that, okay, in this case, I also need to add 1, 2, 3. So he knows that step number 5 is needed here. So then Eric goes back and he can complete the work task and everybody's happy. So this is the purpose, one purpose that the conceptual information has, to allow the user to infer or draw conclusions on the steps to do. And an expert, a definition of expert would be someone who has developed knowledge, can shape a mental model, both procedural but mainly system oriented, from which to draw conclusions on what actions to do. So one word here also about a minimalist instruction, because interesting. If Eric would find a minimalist instruction, the purpose, as I understand it, minimalist instruction, according to minimalism, the purpose is not to allow the user to shape a mental model from reading, but the minimalist instruction should encourage the user to explore and discover the product, meaning to shape a mental model from their own discovery and exploration. And this is the ideas of Piaget, that you learn by discover things, discover the world. So in this case, I think during the conference we have had, there was a lot of questions about the word minimalist. As I understood it, minimalism comes from the idea that technical documentation should minimize the obtrusiveness on users' learning path, meaning to be as little as possible in the way of users' own discovery, but encourage and support users to discover. So minimalism has nothing to do with the number of words or number of pages, or to try to cut words or cut pages. That to me is a complete misconception. But anyhow, let's look into now, giving this view of Eric's behavior, seeking and searching and reading, is kind of rational and systematic. In real world, there's a lot of challenges that happen. So let's look at some of them. Let's again focus on Eric's learning path. And as Eric is in the beginning of trying to learn and trying to shape a mental model, let's look at what happens. So if Eric then, if he would lack the relevant knowledge about the domain, about carburetors and machine, his mental model would become incomplete, and he would have difficulties to infer what actions to do. But also, if his knowledge would be misconceptual or contradictory, he would end up shaping an incorrect mental model, seeing the device and thinking that it is something it isn't. Maybe he has experience of a competitor manufacturer products and thinking that this is the same. So let's look at two examples of how this could happen. So I would ask you to read this text. And then again, ask you to write in the chat if you, the question, why did this man decide not to cross the desert? So how are these two sentences, how do they relate? And then perhaps Alexandra could pick some.
Okay, now they come. Because he did not understand that this sign is only valid in winter. Chocolate or hazelnut dessert. He was in Antarctica. It can get freezing in a desert sometimes. Association.
Yeah,
There is
I
a
think
big
that, that's a good examples. So let us actually replace one word and then we read it again. So the question now is, why did he decide not to cross the lake? Why did he go home? He turned around and went home. I guess you figured it out, so we don't in this case. So what is the difference between these two? Well, we replaced one word, desert becomes lake. Now this has to do with domain knowledge to be able to activate and shape a mental model. Because if you knew in the first sample, the desert sample, if you knew that up in the northern parts of Sweden we have deserts, yes, and there are lakes in these deserts, and during the winter they will freeze, of course. So knowing that heavy objects will break thin ice and you don't want to fall into cold water, these two sentences make perfectly sense. You can shape a mental model. We can bridge these two sentences and make inferences on how they relate. Now, of course, very few of us know about Swedish deserts. So if we replace desert with lake, we can then activate knowledge about winters and how water freezes. And then the second example makes more sense. Because we can shape a mental model, we can activate our knowledge about winters, shape a mental model, and we know why this person decided not to cross the lake. So this is an example of if the user lacks relevant domain knowledge, we're not able to shape a mental model from looking at the interface of the device or from reading, which then makes it difficult to form a goal and to infer actions to do. And this is a beginner who's trying to learn a task on their own will have difficulties if they lack relevant knowledge. So let's look at the second example. And again, if you can read this text. And actually, I will just give you a very short time to read it because our attention span to read text when we skim read to judge relevance is seems that we don't spend too much time on reading. So the question here, there was a famous person here. What was the role of this person? Did you figure out what kind of occupation this person had? And again, if you could write in the, I guess, in the chat window. And
we have a lot of answers. They all say composer, gardener. We have a gardener here.
Yes, perfect. That was looking for. So some things composer.
Why composer shouldn't be composer?
Yes, you got it perfectly. The thing here is that now in bold it says composer, which it should be. The famous gardener is one who composes music and is playing here. So what happens here is an example of a contradiction. When you saw the photo of the piano and the concert hall, you activated your knowledge on concerts and pianos. And then when you read a text, the reader tries to fit what they read into their already shaped mental model. So if there's a contradiction, if you find things, words that contradicts the common knowledge that you have activated, the reading comprehension research tells us that the reader would react, ignore, or reinterpret, having read, in this case, composer. So if I would ask you 1 week after this presentation, you would say, yeah, I was a composer. Definitely, 100% sure, composer. Because what you remember have learned is the things that actually comply with your knowledge that you have. But in this case, it was a composer. So this is also a tricky thing for a learner who in the beginning tries to learn. If their knowledge, maybe from the competitor manufacturer's carburetor, is a little bit different, and they activate that knowledge and they read, they will say, yeah, well, it's a composer, sure. Then when they try to infer the goals and actions to do, try to execute them, yeah, they will fail. So this is an example of where misconceptual or contradictory knowledge can cause issues in forming or shaping a correct mental model. So let's look at some examples here when challenges when searching and reading for the beginner learner. But there are challenges. So let's see Eric here. Now he is in the workshop. Eric is on his own vacation, so Eric, he needs, his information need is conceptual information on how the carburetor works. So he searches, maybe he asks chatbot or Googles on YouTube, and he finds information on how the air filter works. Now, if he lacks domain knowledge completely, he cannot shape a mental model, he cannot understand, and he will skip the information. Yeah, this is not for me. Let's say that he could shape a mental model, but he do it correctly and say, yeah, this is about air filter. Of course, he was into looking for the carburetor, so he judges this not to be relevant, and he skips it. What about if he misconceptually read this as being about the carburetor? So he do the thing as maybe some of you did with the piano and concert example. You reject, ignore, or reinterpret parts and say, this is about the carburetor. And then he would start to infer the actions and the goals to do. Then when he tries the work task, he would fail because, well, this is it's not working. Let's say that he would find information on how the carburetor works. So as technical communicators, we say, yes, you find the relevant information. Perfect. Oh, he lacked the domain knowledge. He cannot shape a mental model. Similar to when you read the first example of the washing your clothes text, he would skip the information. Let's say that he would misunderstand this as how the air filter works. Say, okay, yeah, this is about the air filter, so this is not for me, so he would skip it, unfortunately. Let's say that he would grasp, yeah, but this seems to be about the carburetor, so he continues to read. He misunderstands certain parts, so he rejects, ignores, or reinterprets certain parts, since there could be a contradiction, or his knowledge is misconceptual. Then when he tries to infer the goals and actions, he would fail. Okay, let's assume now that he could shape a mental model, and that is correct about how the carburetor works. And now we say, okay, now I need to press this button or tighten this thing here, but it fails anyhow. So how can this be? Well, it could be because his work task goal was not to assemble the carburetor, it was to assemble the gearbox. So his information need is misconceptual from the point of view of the work task. So this example of how the beginner novice learner is confused, doesn't make any sense, it's just confusing, and maybe user gets frustrated and doesn't know how to do. So this, from my point of view, this boils down to a chicken or the egg problem. You know, the chicken or the egg kind of who came first. So reading comprehension research, and my research reveals that the user needs relevant knowledge, both about the domain and the language, to be able to find relevant information and understand it. So we need to have some domain knowledge to be able to find the relevant section or part, or ask the relevant questions to Google or a chatbot or micro content, and also to shape a mental model from the text we get, or the video that we are looking at. But isn't that I mean, the purpose of searching and reading is to learn relevant knowledge. So where do we start? I mean, was the chicken or the egg? Who came first? So how do we do? Okay, what I'm trying to do in my research is to find other ways of designing technical communication to allow users to shape a mental model that doesn't heavily force them to search and read. So what I'm looking into investigating is designing what I call tangible symbols. So what I'm giving users symbols, giving a random order, as you can see here. And all of these different things, symbols here, they signify a component on the hardware or software, and also results. Remember, when someone is performing an action or trying to accomplish a goal, they perform a number of sequence of actions. Each action gives a result that is meaningful. It's an intermediate result, and those can be signified using these symbols. In the lower left corner, you have the guided exploration card, or the voice of the more knowledgeable other who supports the person to assemble these using their hands into a result model. So when they're done, they have laid a puzzle. So here we have a complete model. So to the right here, we have after the learning activity. The thing here is that this way of designing conceptual information doesn't force the user to only rely on reading with their eyes. You can shape a mental model by using your hands, which means that we can support the shaping of mental model. It seems that using your body and your hands seems a very powerful way of shaping a mental model. Now, this is very similar to a minimalist design. Remember that the minimalist instruction encouraged the user to shape a mental model from exploring the device, the product. What I'm doing here is I'm encouraging the user to shape a mental model from exploring the content. So the instruction you see in the lower left corner is like a minimalist task topic. Okay, if you want to read more about, if you're interested in more on this, just give me a hint. But you have a link to the dissertation. It's called Shaping Thought Through Action. And also in the October issue of the TC World magazine, there's an article which touches upon what I've been discussing today. So you have a link to the PDF if you're interested. So just to wrap it up then. So do we need to write conceptual information in manuals? Well, my point is that we should try to avoid write conceptual information for beginners. Like Eric in the beginning of trying to learn using technical communication. And that is because beginners lack relevant domain knowledge to be able to shape a mental model to support finding and reading. And since they lack relevant domain knowledge, they are likely to face these challenges. But conceptual information can fit a purpose for more advanced users. In this case, advanced users mean someone who is, remember the arrow for the learning path, or at the end of the learning path. They have developed knowledge, they're maybe more certain about what they're doing, and they lack some detail. So for those users, conceptual information serves a purpose. And also for users who have learned some year ago but want to refresh their knowledge. Okay, this was the way these parts relates together. So this would be my advice based on looking into these aspects. So I guess that's it. So I would say thank you for attending this last session of TC World. And yeah, I think there's some time for questions.
Yes, we have some questions coming in. The first one, is conceptual information the responsibility of training or, oh, sorry, I cannot see it, or documentation functions?
Yeah, that's a good question. To my experience, I think both training and technical documentation deals with conceptual information. So both has, well, responsibility or are designing conceptual information. So I think conceptual information fits a purpose. For training, the thing with training is that then often there is a trainer who is the more knowledgeable other, who can act as a scaffold and support. So that is a little bit, when someone is acting in person, I guess that conceptual information could be relevant. I haven't looked into specific training situations like that, but I think that in that case, conceptual information can fit the purpose.
Then there is another very interesting, important question: how to decide which amount of conceptual information is enough?
Yeah, that's also a really good question. Because I think that depends on or really understanding your users and what domain knowledge that they already have. I think that's a challenging task for us as technical communicators, because we are targeting a specific audience. So we need to know things about them. But one thing to know is, what do they know? What kind of domain knowledge do they already have, which we can build upon? And then design the information that builds upon what they already know. So that would be my answer. But that is a challenging task, which I think more research would need to look into to find out what is appropriate, a level. But understanding your users is so crucial and so important.
Thank you. What about using a more visual information or for conceptual content? Diagrams, concept maps, schematic drawings, like the ones you used in these slides?
Yeah, I think that's also an interesting question. Text versus images or both. I think the research shows that both text and images are more powerful than text or illustrations or visuals alone. But when it comes to visuals, I know that there's visual literacy. We need to be knowledgeable on how to read and interpret a diagram or an exploded view or a visual. I know my supervisor, Professor Yvonne Eriksson, she looks into visual literacy and visual communication. And it seems that we need to learn how to read an image equal to being to learn how to read text. For instance, if you have 3D perspectives, etc. So I think both text and image in that case is more powerful. But again, from visuals, you also need to shape a mental model. It's not like the Nuremberg funnel that you pour information into the head. You need to interpret and shape this mental model, also from visuals.
Thank you. In a different presentation this week, Dieter August proposed to use concept maps to help readers understand conceptual information. Is this something you are familiar with? What is your opinion on that?
Yeah, that's a good question. I think that's, I didn't actually attend. I have to look at that particular presentation. I think perhaps my view of concept maps is a way to guide the user into shaping a mental model about, for instance, how a system works on or departs it. So it's a way of designing conceptual information that I think could be fruitful. I haven't specifically looked into this. I don't really know at this time.
And for the beginners, a question: is it helpful to rather illustrate than to write some basic model?
From my perspective, I think that text and images together is the more powerful than text alone or an illustration alone. So I think that research shows that text and images together makes it easier to understand, meaning to shape a mental model. But it also depends on the users and their domain knowledge and what they are familiar with. So I think these aspects are really crucial when designing. What kind of products has to be used to do what is their domain knowledge, basically.
And we have a question regarding your conclusion. What if I can't provide different information for different target groups as in a classic instruction for use?
Yeah, that is also, of course, a challenge. So this conclusion implies, as the questioner asked, that we divide and design content for the beginner and for the more advanced user. So I know that there's some examples of where you explicitly, like metadata, saying that this text is written for the more advanced user. And of course, a beginner, we cannot stop them from reading it. But if we declare that this is written for an audience who we assume know a lot of things. So I think this is a task that we need to do as technical communicators, to understand what knowledge do our users have, and then my design depends upon what I do believe that they know. Remember the example of reading the sentences about the lake and the desert in Sweden. So to be able to write sentences, and the reader needs to bridge these sentences to make inferences based on their knowledge. So we need to know, what do we assume that they know? We can explicitly say that this is written, I'm assuming that you know this and this and this. If you don't know it, then please go, you can read about these basic aspects somewhere else.
As information architect, you probably have a lot to say how one can make manuals modular so that it can be tailored to the individual reader's needs by the readers themselves.
Yeah, that's another interesting topic which I'm also interested in. In previous TC World conferences, I've been talking about users' information need, and that we can design, modularize content, that a topic is an answer to a user question. So that way of designing means that we first need to predict what type of questions is it that the user is assuming to ask, and then design the answers would become a separate topic for each answer. And then we can use, I've shown examples of using faceted navigation or parametric search to be able to find a specific answer depending on your search situation. Let's say that I am an installer, I'm a beginner, I want to know about the carburetor for this type of product version, this and that. So you can filter a knowledge base of answers that has been predicted by a technical communicator. But information need is a very central concept, which I have touched upon here, but something that is, yeah, it's a complex concept.
Mm-hmm. What if conceptual information can also be drawn from the internet? Does the user usually prefer this?
Yeah, that's also a good question when it comes to users' searching behavior. I think what I've been looking into when it comes to seeking and searching behavior is that when searching, accessibility is one criteria which many of us use. So we try to find the information source which is most accessible. So that means that if I ask Google and find a page and I read it, that seems likely that that is what we do, because since accessibility is major called a source preference criteria, where we're trying to evaluate and read an information source. So user generated content, yes, that could be a source for many users.
Mm-hmm. Another interesting question, images of a product may change, but the names of parts remain the same. From a budgeting point of view, it may appear cheaper to focus on words than images. Do you agree?
Yeah, that's a good, yeah, I think perhaps there's a tendency to, that words are easier from a maintenance perspective, of course, to change than changing an image. So I think that's a tendency. That's true. But I think probably nowadays there are tools also for changing illustrations, which could be a support to be able to also update illustrations once the part or the terminology of the product changes. But I think the tendency is that we usually prefer to manage that as text.
Mm-hmm. Okay, let's see. Wouldn't progressive disclosure for conceptual content be helpful? Use a hierarchy of topics.
Yes, that could be one way when designing, I agree, to progressively disclose and to hide and to reveal details, to start from an overview for the big picture, few details, and then zoom into and dive into details. And that's actually something that I work with Excosoft and our Scribenta. It's used based on the principle of expanding and compressing. That first you provide an overview, you can zoom into your content by expanding. That's the name of Excosoft, expand, compress. So it's a principle that you zoom yourself into the details by expanding a content structure. So I think that's a way of progressively disclose information in layers. So I think absolutely, I think that makes sense.
What would you say about organizing conceptual information in relation to how-to information?
That's also an interesting question. And there's a lot of research in technical communication and in reading comprehension research looking into the difference between supplying conceptual information as a separate text or embedded within instruction steps. It seems that when certain conceptual information is embedded within a procedure, that makes the efficiency of the work tasks better. And there's also research looking into allowing the user to read conceptual information and then read the instruction. So there's a lot of experiments that have been done on how the users has been interacting with the two information types. But embedding it within the instruction seems to be supporting the efficiency of the work task.
So I hoped I didn't miss any question. If there is more questions, you can still use the cafe. I think I'm not sure until when. Claudia, do you know maybe? But I'm sure you can also email our presenter and ask.
Of course, if you have any questions, yeah, please contact me if you have any questions. I'll be happy to interact with you.
So I would like to thank you all that you still were able to come to this last presentation. I wish you all a very good weekend, and I hope you had a nice first Digital TechCom event. I hope you got new ideas, and I hope we will see each other maybe soon, maybe live, with some new exciting topics. Thank you and goodbye.
Yep, thank you. Thank you all. Goodbye.